Oh, good morning, everybody. It is April 29th. Here we are again. So I want to talk to you about a couple of things. First of all, scheduling is coming up, and if you are really having a hard time with algebra, with geometry, and math is really a struggle for you, please don't sign up for Algebra 2. Algebra 2 is more like a get you ready for college level math, okay? If Algebra 2 is going to be a lot harder than geometry, and so if geometry is hard and math and everything, take personal finance. You can get your 3 credits. You don't need Algebra 2. However, if you're going to college, to a 4-year college, you need Algebra 2. If 4-year college is in your plan, you need Algebra 2, and then you may as well get used to working hard because college is not easy. Talk to some of your friends. Okay, so first of all, keep working. Okay, get caught up. Again, I want to give credit for everybody. Most everybody's working hard. It's difficult, but if you can't do anything, you don't deserve any credit. If you do nothing, you don't deserve any credit. So you got to keep working. Get moving, okay? Answers from yesterday. Let's take a look at that real quickly. And where is it? We're in 7-2. So here's my answers. This is easy. You guys agree? This is real easy. Okay, so here we go. Number 1, I get 10 and 40. I think these are the same problems I gave you in the notes. 21.5 for x and 415 for y. 3x is 6, y is 8, 4pq is 24, oq is 14, no is 26, pq is 20.7, angle, PMN is 112, OPQ is 68, and MNN is 59. These opposite angles are going to be equal because those are parallel. Okay, there it is. Cece asked about how do you find this other angle. She wanted to know about this angle right here. And it is 53. You didn't need to know that, but you add them all up from 360 and then divide by 2 and you get 53 and 53. Okay, so that is the answers from last night's homework. Okay, so now let's move on. This is an easy unit. I think you guys will all hopefully agree. So to start off with, first of all, let's talk about today's notes. Okay, so our objective deals with converses. Converse is just like the opposite. It's just saying the opposite. We'll say opposite statement. Oftentimes in if-then form. So an example would be a parallelogram is a quadrilateral with opposite parallel sides. Right? That's just its definition. Okay? That's it. Parallelogram is a quadrilateral with opposite parallel sides. So, how do we say it's converse? It's converse. Let's just say the opposite. If we have a quadrilateral, so the converse would look like this. I'm going to say just the opposite. So we would say a quadrilateral with opposite parallel sides is a parallelogram. Let's see if we can see the opposite of that, okay? So this is just the opposite. So what we're going to do is we're going to say, instead of saying it is a parallelogram, we're going to say, well, we've got a quadrilateral with opposite parallel sides, so therefore it is a parallelogram. It's just saying the opposite. First statement says it's a parallelogram. Because it's a parallelogram, we've got these opposite sides. Now we're going to say, hey, wait a minute. I've got a quadrilateral with opposite sides that are parallel. It's a parallelogram. So that is what makes a parallelogram. So then, if we want to know if something is a parallelogram, let's go to our journal first. Okay, so I go to my journal, And the nice thing about the journal is it's got all this stuff in it for me. So I don't have to do too much, but here it is. Okay, so this is proving that something is a parallelogram. Okay, so let's just say this is just a four-sided figure. We don't know, it's just a four-sided figure. But, okay, it's quadrilateral. But if opposite sides are equal, it's a parallelogram. Okay, they call that a theorem, so it's a rule. So it's the parallelogram opposite side converse. Remember, there's the converse. So what we're doing is we're saying that it's a parallelogram. If opposite sides are equal, it's a parallelogram. Okay. The other one is, so I've got this four-sided figure. Big deal. Except if opposite angles are equal, it's a parallelogram. Okay. So I've got the four-sided figure. Opposite angles are equal. It's a parallelogram. Okay. So there's its rule. This one's kind of new, but sure enough, if you have two sides that are parallel and they're also equal, it's got to be a parallelogram. So if you've got this four-sided figure where these two sides, so we can say that BC is parallel to AD, and we can say that BC is congruent to AD, then we can say, hey, this thing is a parallelogram. Parallelogram, yeah. Okay, and then we go and have another. Okay, so it talks about diagonals. So we've got this four-sided figure. Great. What is it? Well, because the diagonals bisect each other, we know it's a parallelogram. So what I did is I took my notes, and then they got this really nice little thing here that puts it. Now we're not cutting and pasting anymore, but I did that anyway. So I thought, okay, well, what if I took and made it easy for myself? And I cut that out, and I've got list all the conditions to prove parallelogram. So I cut it out. I'm going to paste it into my journal here, and I've got it. Now you guys obviously don't have to do that, but I'm going to do that anyway. Okay, so I almost left the tape in the house. Okay, so boom, there it is. Tape that in there, and I've got all my conditions. Okay, so I've got opposite sides are parallel by its definition. That's a parallelogram. Okay, I've got opposite sides are equal so therefore it has to be a parallelogram. If opposite angles are equal, therefore it's a parallelogram. If one set of opposite sides are parallel and equal length, it's a parallelogram. If diagonals bisect each other, it's a parallelogram. Okay, so I've got that in my journal. These are all the conditions. So, all right, let's take a look at example one. So, example one, let's prove that it's a parallelogram. Okay, so first thing I'm going to do is graph it. -3. 3 is A. 2 and 5. 1, 2, 3, 4, 5 is B. 5, 1, 2, 3, 4, 5, and 2 is C, and 0, 0 is D. Okay, so I'm going to go ahead and draw it in my parallelogram. Get my pens out here and draw that in nicely. We'll take a look at this thing, okay? Sure looks like a parallelogram to me, doesn't it? Yep, but you can't just say it is a parallelogram because, you know, it might be off by a little bit. You might say, wait a minute, how do you know that's a parallelogram? Alright, so there we go. There it is. So we've got all of these ways to prove it's parallelogram, okay? So we could say the opposite sides are parallel, maybe. Opposite sides are congruent. That would take us to find out the lengths of these. Looks kind of hard. Opposite angles. I don't know the angles, so that looks kind of hard. Opposite and parallel. That looks kind of hard. Diagonals. I have to draw the diagonals to make sure they bisect. But I think in this case, the first one I'm going to use is the definition. Okay, so because I can find the slope. So if lines are parallel, if I want to show that AB is parallel to DC, okay, and if I want to show over here that AD is parallel to BC, I'm just going to work on the slopes. Because I know that if two figures, if the slopes are equal, they're parallel, okay? So the slopes are equal. So I'm just going to count the slope. That makes it really easy. So let's go AB, okay? So let's do some countings, okay? Right, slope is rise over run. Rise over run. So let's see, from A to B, I'm going to count. 1, 2, 1, 2, 3, 4, 5. up 2 over 5, and from D to C up 1, 2 over 1, 2, 3, 4, 5. Slopes are the same, so there, boom. Those two are parallel. I know that for sure, okay? And the same thing with AD and BC. I'm going to go down, rise around, down 1, 2, 3, 1, 2, 3. So I went down 3 over 3, or negative 1. And B to C is down 1, 2, 3, 1, 2, 3. Sure enough, negative 3 over 3. So therefore, those are parallelogram because they have the same slopes, okay? Same slopes. So therefore, we can say that little statement. We can say, and I'll use this little symbol. See my little symbol? Parallelogram A, B, C, D is a parallelogram. I'm proving it's parallelogram. All right. Awesome. I proved it's parallelogram because opposite slopes, opposite lines are equal. I'm sorry, opposite lines are parallel because they have the same slope. Okay. All right, let's turn the page. All right, now here's a couple examples I took. Now I'm not much of an artist, so use your imagination. That looks like kind of like a parallelogram. Not really, but Anyway, here's what we're going to do. So let's make it a parallelogram. So let's make this a parallelogram. How do you do that? Well, if opposite sides are congruent, then it's a parallelogram. So let's find the value of x. So x is what and y is what to make it equal. Okay, so first of all, if I can make this side here equal to this side here. So let's just set them equal and make the value of x. So let's go x plus 9 equals 2x minus 1. If I can find the value of x to make them equal, let's do it. Okay, so let's solve minus x. I've got a 9 equals a 1x minus 1 plus 1 plus 1. So if x is 10, plug it in. If x is 10, I plug it in 10. This side's got to be 19. X is 10. I get 2 times 10 is 20 minus 1 is 19. Okay, good. So if x is 10, then this side is equal to this side. They're both 19, 19. Okay, how about the y? Well, if x is 10, let's plug that in. Okay, if x is 10, let's plug 10 right in there. So we're going to go 10 plus 7. This side's 17. Therefore, y had better be also equal to 17, so that this side is equal to this side. Y's got to be 17, so 17. Okay, we've proven it. We've proven it's a parallelogram because opposite sides are congruent. Boom, got it. Example 2. All right, in example 2, I've got the angles, right? So what I want to do is make my opposite angles congruent. Okay, so let's start with this one. Let's try and make this angle here congruent to this angle here. Okay, to do that, let's set them equal and solve for x. Okay, so let's go and set 2x equals to my 3x minus 32, and let's solve for x. Okay. Let's see, I'll go minus 3x, I get a negative 1x equals a negative 32, right? Divide by negative 1, divide by negative 1, and I get x equals positive 32. Okay, so let's plug it in. Okay, positive 32, let's plug my 32 right in there. So 2 times 32 is 64. So this angle has to be 64 if x is 32. Plug it in. Let's see. Let's just see. Let my calculator do the work for me. And remember, x is 32. So I'm going to go 3 times 32 minus 32. Okay. Sure enough, 64. That's what we needed. 64, 64. Okay. So this angle is equal to that angle. Now, if x is 32, what about y? Well, again, set these two equal. So we'll go 4y equals to a y plus 87. Go minus y, right? We're just going to solve for y. That's easy. I got a 3y equals 87. Divide by 3. What's 87 divided by 3? That's what calculus made for. Boy, the other day, remember Monday when I didn't have a calculator, I had to do it by hand? 29. So I get y equals 29. So plug it in. Put 29 there, 29 there. Okay, take my 29, plug it in there. So I'm going to go 29 plus 87. Boom, I get 116. Okay, so this angle's got to be 116. 4 times 29 better be 116. It is. So this is a parallelogram. What I've proven is if x was 32 and if y was 29, I've proven that the opposite angles are equal, therefore it is a parallelogram. Awesome. Okay, last but not least, okay, it looks like diagonals. So I got my little chart here, and sure enough, if diagonals bisect each other, it means they've got to be equal. This diagonal's got to be equal to that diagonal, and that diagonal's equal to that one. So we've got a little bit of help. First of all, in this example, they already said this is equal to this. So this diagonal's already got one diagonal is equal to the other. So this diagonal is equal to that diagonal. Awesome. However, I want to make this diagonal be cut in half. Therefore, this piece of the diagonal has to be equal to this piece of the diagonal. So to do that, let's set this piece of the diagonal equal to this piece of the diagonal and solve for x. So 5x minus 8 equals 3x. Solve for x, go minus 5x minus 5x. Negative 8 equals negative 2x, right? Divide by negative 2, divide by negative 2, and x equals 4. Okay, so let's plug it in, find out what we got. Okay, so plug in 4 in here. 3 times 4, that's easy. That's 12. That means this diagonal here is 12. Plug in 4 in here, and you get 4 times 5 is 20. 20 minus 8 is also 12. So therefore, this piece is equal to this piece, so the diagonal is cut in half. This piece is equal to this piece, so the diagonal is cut in half. Therefore, it must be a parallelogram. We've proven it's a parallelogram because diagonals are cut in half. Diagonals are bisected, okay? Bisected diagonals. Okay, so in homework today, it's pretty easy, except you need to show your work. So let's take a look at it. We're going to go to page 237. Page 237 in our journal. Golly, I'm glad we have journals. Makes it so much easier for everybody. 237. Okay, here it is. Page 237. Page 237. I want you to do 1 through 7 all. That's it. Easy. Okay? Number 1, you just have to say yes or no. Is there enough information? If there is, you have to say what. Which one of these rules is it? Okay? There's not enough information there. Okay? Number 2 looks like maybe that one, so you have to say what it is. Number 3 looks like that one, so you just have to say what it is. 4, you've got to find the value to find out which one it is. Now 4 is a little tricky. I'll set you up with 4. These two are supplementary, so you got to start with 3x minus 20 plus x plus 40 equals 180. That's one of those rules we found, is that these have to be supplementary added up to 180, okay? And then the rest are easy. Find out the diagonals. You got the diagonals. Opposite sides are equal. You can get the angles to be equal, okay? Alright, there's your homework, and good luck. Make sure you show your work and keep working. We're going to get this done.